Welcome back, everybody. We are going to now be working with 7th grade and specifically dealing with geometric figures. Now, just looking at this, okay, I should bring it back with geometry. A lot of this has to do with scale factors. I already see the vocab right here. And to me, automatically, vocab scale factor is your multiplier, aka, okay? Um, a lot of it's depending on your teacher. We do ratios 1 to 4, which is kind of telling you what your multiplier is, and we'll talk about that in a little bit if you learned it that way. Yeah, because I see a lot. Look, scale fact. There's my ratio. Sorry, ratio. And it's always 1. See, 1 to 2.5. So it's a big hint that I'm gonna give you. Then we got a cube. So that's a shape. It looks like we got some other stuff going on there. Word problems, some true and false, and that's it. So 11 questions. Not horrible. Let's get through these as fast as we can, but as accurately as we can. All right. Hopefully, I don't have too many mini lessons on this one, but we'll see. Okay. Don't be whining already. Okay. Those are important for all of us. Okay. They're good recaps. Okay. Can already tell some of you guys rolling your eyes. Okay. Ay ay ay. Anyways, moving on. All right. Figure A is a scale image of figure B. Okay. Sure. The scale map. The scale that maps figure A onto figure B is 1 to 4. So in other words, that means if this had a length of 1, this would have a length of 4. Okay? So enter the value of x. So here's how it works, right? Essentially, what we do a lot, it's the same kind of steps, right? It's the same strategy usually. When we're going to find this is we just got to figure out how we get to x. So we're going to use corresponding sides. So what that means is the top side should correspond with this top side. The left should correspond with that. The bottom should go with the bottom. And the right side should go with the right side. What I know is this one goes with that one. So 1 goes with 4. The same way that x goes with 12. So here's the kicker, right? I said your scale factor, aka your multiplier. How did I go from 1 to 4? What did I multiply by to get to 4? So in this case, I said 1 times 4 equals 4. So that's true. So if I go from x to 12, I'm going to say, and no, this is where I get it, right? Look, hey, there's my multiplier. 1 times 4 equals 4 to go that way. I'm going to go like this because that looks like division. So what do I do if I want to go backwards? So if I have to multiply times 4 to go to the right, to go to the left, I have to do divide by 4. So if I say 12 divided by 4, I'm going to get 3. Does that make sense in the long run? Well, let me see. If I put a 3 here, 3 times 4 equals 12. Yes, that's true. So if you notice, what was my multiplier? Okay, this is a big hint right here. My multiplier, aka scale factor, was this one. I went from 1 to 4. Okay, 1 to 4. And because I started at 1, I have to multiply by whatever my second number is. Okay, and you're going to see a lot of these that start with 1. See, 1 to 6. How do I get to 6? I multiply by 6. And we'll get there in a little bit. Oh, here it is again. And this one, yay, calculator, so this will be awesome. So same idea, if this was a 1 on the left side, the corresponding side on this left side would be 1 3/4. So how did I get from here to here? I multiply by 1 3/4. So how do I go from left to right to get from 8 to x? I'm going to multiply by 1 3/4. So let's use our calculator because that's a crazy number. Okay, and you guys love fractions, don't you? But calculators are going to be easier this way. So I started with 8, and I'm going to multiply times 1 3/4. And I'm going to get 14. There, that was it. That was my multiplier, aka right there, multiplier, aka scale factor. Okay, that's your vocab. And we do that only because the 1 is on the left. Okay. All right. Let's go to number 3. So figure A is a scale measure figure B. Enter the scale factor, aka multiplier, when applied to figure A, would produce figure B. So how did you get to figure B? So let's look at our corresponding sides again. 4 goes with 20, 5 goes with 25, and 3 goes with 15. So if I were to write these into ratios, right, how did I go from 4 to 20? So how did I go from here to here? How did I go from 5 to 25? And here, there's a little mini lesson here. Okay, sorry, got to do it because this will help you for the whole thing. And then how did I get from 3 to 15? So because these two figures are a scale image of each other, they're similar. Okay, more vocab for you. That means I have to multiply by the same number. So 4 times what is 20? 4 times 5. 5 times what is 25? 5 times 5. 3 times what is 15? 3 times 5. So what is, in the end, my scale factor? My scale factor is 5. I multiplied figure A to get to figure B times 5. Okay? So again, figure A is a scale measure of figure B. The scale that maps it is a 1 to 6. So let's say this was my 1. This one right here would be my 6. So how did I get there? So from 1 to 6, I multiplied times 6. So if I'm going to go from 8 to x, so 8, 2, because that's what this means, x, guess what? I'm going to also multiply times 6. And 8 times 6, can I use a calculator? No, so I can't cheat. I'm going to get that out of here. All right, no calculator. How good are you with the multiplication tables? 8 times 6 is 48. All right, next one. They have a calculator, and I can see why, because I see a decimal there. Okay, not bad. It's not too bad, not too horrible, hopefully. So enter the scale factor, aka the multiplier, when applied to figure A, that would produce figure B. So how do I get from figure A to B again? In other words, how did I get from this one to that one? They didn't give me a scale factor. They didn't give me a ratio. What is my ratio? They didn't tell me. So in this case, I know it's 1.5 to 12. So how do I get there? What do I multiply by? So let me think about this a lot. Just let me use a different example here. If I had a number, because we've been using 1 and something, right? So if I say 1 to 6, how did I figure out that my multiplier was 6? Well, remember, multiplication is related to division. So I went backwards, right? Like if I went backwards, I divided by 6. So how do I get the number on the left? Well, I could have just said 6 divided by 1. Clear. 6 divided by 1. And that gave me my multiplier. So right here, can I go backwards? Well, I can say 12 divided by 1.5, and that gave me 8. Does that make sense? I don't know. Let's double check. If my multiplier is 8, aka scale factor, let me do this on the calculator. 1.5 times 8 equals 12. Yes. So another little shortcut that we learned here, and I like to use this, is where you're going, right? This is where I start, and this is where I end. So very, very simple thing to find. Your scale factor is basically division. Do you see this? Dividing. So I am dividing the number that you end at over where you start. Okay? So I ended at 12 and I started at 1.5. So 12 over 1.5 is 8. And I'm going to show you it's the same thing for these, right? 14 over 8. So if I do this, my scale factor, 14 over 8. Let's see, 14 divided by 8. And I get 1.75, which is 7 over 4. And 1.75, can you see? 1 3/4. 3/4, 75 cents. If I do it here, 12, right? I ended at 12. I started at 3. So 12 divided by 3. And guess what my scale factor is? My scale factor is 4. So again, mini lesson. Super important. Makes our life easier here. All right. This one, they gave it to us, so it's not bad. The 1 is first, so that is my scale factor, aka my multiplier. So how did I get from 4 to 10? I multiplied times 2.5. Let me just make sure. 4 times 2 and a half is 10. So now I'm going to do 6 times 2.5. So I'm going to go here, get rid of the 4, put a 6. And 6 times 2.5 equals 15. Not that bad. Now it's getting faster, right? It's becoming easier, especially with the calculator. Because the calculator is awesome. All right. All right. Next one, no calculator after I just said that, huh? Choose all the figures that could be formed if you sliced a cube horizontally. Okay, like that. Parallel to the base. So your base looks something like this, right? So your base is basically the bottom. Can you tell? Can you see it? It's this right here. So if you were to slice this horizontally, I am slicing it like that. Horizontally. Okay. Choose all the figures that could be formed. And if you've seen on any of my videos with select all or choose all, if there's 4 options, we're going to pick 2 or 3 usually. Okay. Can't pick 1. So I have to say this every time just in case it's your first video. If I pick 1, it probably should have been a multiple choice. And if I pick 4, that is super ridiculously rare. I mean ridiculously rare. Okay? For the 1,000th time, my joke is, when I was your age, we used to have something called all of the above. That doesn't exist anymore. I hated that answer. Okay? I'm sure a lot of us did that are my age or older. Okay? Now it's just choose all. So pick 2 or 3, right? Not all 4, not 1. So in the middle, 2 or 3. Anyways, if I slice it, essentially you're asking, like, what shape did I get right here? Well, it's not a triangle. And if it's a cube, all the sides are square, so it has to be a square. And you're like, a trapezoid. Do you know what a trapezoid is? I always think of Pizza Hut. There's a trapezoid. Does that look like a trapezoid? No. And then you'd be like, well, Beltran, I'm done. There's only a square because the square's on the bottom. But here's the thing. It has to do with vocabulary. Okay, and this is where it gets more annoying into like 8th and like 10th grade when you take geometry, if you do it at that pace. A square is special in that it is a rectangle as well. Because a rectangle says that the top and the bottom are the same, and the right side and the left side are the same. And all the angles or the corners or vertices are 90 degrees. Well, a square is the same thing as a rectangle. If I use the same definition, right, the top will be the same as the bottom. Isn't that true on a square? The left will be the same as the right. Isn't that true? Aren't all the corners 90 degrees? So they share the same kind of characteristics, okay? So this is why it's important to know, pick 2 or 3, because I have a feeling most of you guys would have just said square, and you're like, I'm done, okay? That's your big hint. You kind of have to think about it, right? Like you had to go with your gut and be like, all right, a rectangle, I guess it could look like that. Even though most of us will say this is a rectangle. This is also a rectangle and a square. Okay. Anyways, moving on. A triangle has a 90-degree angle and a hypotenuse length of 15. Choose true or false for each statement. Alright, so again, I've said it many times, just like the select all, this one is not going to be all true or all false. It should be a mixture, okay? So one of the things I always tell my students, if it tells you a shape, anything, just in geometry, just draw it. So this one's a triangle. There's my triangle. Now this triangle is special in that it is 90 degrees. So if it's 90 degrees, that means it makes a right triangle. What am I talking about? I am talking about that right there. So I'm going to get rid of this triangle. That doesn't count. The thing that makes it special is that across the 90 degrees is your hypotenuse. Okay? And the hypotenuse is 15 here. Select true or false for each statement. Okay, so let's see what we learned here about right triangles. Excuse me. The triangle must be a right triangle. I literally just said that. So yes, it is true. It has to be a right triangle because one of the angles is already 90 degrees. One of the sides of the triangle could be 15. Here's the thing about right triangles. In a right triangle, this is your hypotenuse and the other ones are your sides. The thing that makes your hypotenuse special, aside from it being across the 90 degrees, it will always be the longest side. Okay? So again, little mini lesson here. It's vocab. Okay? You got to know the differences between, like I said, squares and rectangles and these types of triangles. So if I just told you your hypotenuse is the longest side and one of the sides is already 15, can this side be 15? No, it can't. Because 15 is already the longest sides over there. That means that this one has to be smaller than 15. It could be 14.9. I mean, that would be weird. It could be 12. It could be 10. It could be 6. It cannot be 15 because the 15 is the longest side. All right. And then lastly, a second angle could be 45. Do you remember? Actually, I'll leave this open. What all the angles add up to in a triangle? All the angles add up to 180 degrees. So if this one is 90, can one of these be 45? Yeah, because as long as you don't go over 180, you should be okay. So it could be 45. And if I do 90 plus 45, that's 135. And if I do 180 minus 135, guess what? I equal 45. So that's a special triangle, which you will learn later. Okay. So in this case, yes, it could be 45. Okay, because then the other one will be 45, and that adds up to 180. So it's fine. All right, number 9 over here. Calculator. So let's bust it out. Okay. Let's clear this. So a rough blueprint of a house is shown below. The scale to the blueprint of the actual house is 1 inch to 4.5. That's important. What did I go over earlier? 1, 2, because that's your ratio, 4.5. In other words, that is your multiplier, aka your scale factor. Yay. So every inch you multiply by 4.5 basically, right? So that's an inch, that is feet. So using the scale given, enter the actual width of the master bedroom. So notice they gave me a number. It's 2.4 inches. Your job is to do the width of the master bedroom, which is right here. So what is it? Well, again, how did I get from one to the other? I multiply by 4.5. So to get from 2.4 to the other, I multiply by 4.5. So calculator time, 2.4 times 4.5, and I get 10.8. So not that hard, right? And a lot of you guys probably just in a hunch, you'd be like, oh, I'm just going to multiply. Yeah, you just multiply by whatever it says, right? Okay, next one, still a calculator, so let's leave it up there. So Mr. Beltran has a rectangular workbench. I see a rectangle, or I heard rectangle, so I'm going to draw a rectangle. that measures 24 by 36. Okay, so 24 shorter, so whatever. I'll just do it like this. He plans to make it larger. Okay, so I'm going to make it bigger. So I'm going to draw a bigger one. Again, not to scale, but it's a rectangle to a bigger rectangle. By a scale factor of 1/3. Wait, what? That is totally wrong. I had to fix that somewhere. Yes, I did. Let me fix that right now. I put 2 and 1/3. Man, that looks gross, huh? So let me make this a lot nicer. That does not make sense. All right, and if you're clever about it, you'll know why. So I got 2 and 1/3. Okay. I'll explain it at the end. If you got it, great. If not, something to think about, okay? Again, I'm making all these problems up, and like I tell my students, sometimes I screw up, right? Like I'm trying to do these off the top of my head. All right, and I did fix. I just gotta make sure I fixed it on the actual thing. Yes, I did. Okay. Alrighty. So my scale factors are enter the area in square inches of the larger workbench. So the area, remember, is length times width. So the thing is, I gotta get from here to here and here to that one by multiplying by 2 and 1/3. So let's do that. I'm going to take the 36 and I'm going to multiply by 2 and 1/3. Is that 2 and 1/3? Yes. And I get a total, of 84 inches. Okay. Then I'm going to take the 24 and multiply that by 2 and 1/3. And I'm going to get 56 inches. So if I do length times width, I'm going to get 84 times 56. And if I do 84 times 56, I'm going to get 4704. So 4704 will be my area of the larger workbench in square inches. Now, if you're a little confused, like why did I switch it? Okay, because I'm doing this answer key for you guys, and I'm making sure that I have the actual paper that's going to come out with it, or the handout. And yes, I switched it to 2 1/3. So if I multiply by 1/3, think about it. I am multiplying by something that's less than 1. So if I multiply times, and this is what you should have learned in 7th grade, again, if you multiply by 1, it stays the same, right? Anything times 1 stays the same number. 3 times 1 is 3. 4 times 1 is 4. 10 times 1 is 10. If you multiply by more than 1, it should get bigger. So if I multiply by less than 1, it should get smaller. So I had 1/3, remember? So if I do 24 times 1/3, look at what my answer is. It shrunk to 8. And what did it say? I made it larger. So that's why I had to fix it. Okay, if you got that, great. If not, there was another little mini lesson. Okay, scale factors. Super important to know. Is my answer going to get bigger or smaller? All right. Okay, last one, number 11, right? Yep, then it's geometry. Okay. I use a calculator, so I'm going to leave my calculator. A triangle has two angles that are 40 degrees. All right, so I have a triangle. Two angles are 40, and a side is 10. So here's the thing. You're like, where do the 40s go, Beltran? Well, one thing I know for sure, and again, knowing your triangles and classifying, if two angles are 40 degrees, remember our triangles, we have an equilateral, we have a scalene, and we have an isosceles. And this is where my autocorrect always screws me over. Okay, did I spell it right? Ugh. Anyways, moving on. That's not important to me right now. So equilateral means all sides are equal. Scalene means no sides are equal. Isosceles means two sides are equal. So that is super important, because if two of my angles are the same, two of my sides are the same. So that makes it an isosceles triangle. So maybe I can say that is 40 and that is 40. Or I could have gone like this and say that is 40 and that is 40. Okay? Like, it doesn't matter. I just know two of them have to be 40. All right. Is there anything else I can do with this? The 10 can be anywhere, right? Unlike this one right here, I knew that the sides had to be on this one and this one, okay? Because it couldn't be a hypotenuse. Does this one have a hypotenuse? Well, how do I check? I also told you guys that all triangles, the degrees inside add up to 180. So if this is 40 and 40, I'm going to take 180, get rid of 40, get rid of 40, and my leftover is 100. So let me double check. 100 plus 40 plus 40, not 40. Okay, there it is. That is 180 degrees. So because I know two of them are 40, another one has to be 100. The thing that's tricky is I don't know where that 10 is. So is the 10 going to be here? Is it going to be here? Is it going to be here? Or is it going to be here? I don't know. I don't know why it's doing that. So now let's read the questions. All right, let's see. And again, they cannot be all true. It can't be all false. So let's see what we got here. The triangle must be an acute triangle. Acute. That means it has to be less than 90 degrees. And again, vocab, right? Less than. Are all your angles less than 90? No. Right? I have 100 degrees there. So that is false. Okay, next one. The triangle must be an obtuse triangle. Is that true? Yes, that is true. And if you're like, where'd you get obtuse from? Remember, acute is less than 90 degrees. And obtuse, if I go like this, actually, let me go like this. This is 90, right? An obtuse angle is going to be more than 90 degrees. So what's more than 90 degrees? 100. The third angle must be 100. Yes, we figured that out, right? By using the 180. And one of the sides must be 10. Okay, this is where it gets crazy because it's, stuff you learn if you learned it in 7th grade. It's the angle-based theorem. So what does that mean? So it's basically telling you if this is 40 degrees, across is a 10, then this is 40, across should also be a 10. Okay? They have to match because the two angles are the same, two of the sides have to be the same, which is true. Okay? So if the 10 was there, it would totally be okay. Where is the problem? The problem would be if the 10 was in the bottom. Because this angle, I don't know what it is. And that angle, I don't know. That side, I don't know what they are. I just know they have to be the same. So if the 10s were across the 40s, then they would work. The question is, or the trick is, it says it must be. No, it can. So this one is going to be false. Okay? So right here, right, doesn't work. Right here, it does. But again, it didn't tell me where the 10 was, so I can't say for sure that it has to be. All right, tricky questions there. All right, so that was it. Okay, so a couple things to remember, right? A lot of vocab right here. I had to throw in equilateral, scalene, isosceles, acute, obtuse. You have to know that triangles are 180. You have to know right triangles, hypotenuse. Wow, it's a lot of crazy vocab here. Most of this, though, I think you guys will be okay with, which is kind of good, right? Your multiplier and your scale factor, hopefully by today you're a little bit more comfortable, okay, and understanding how to get there. Here's one way to get there. Your scale factor, you just put the number you end at over the one you start, or you could have figured it out by doing that. The other shortcut was if you started with a 1, right? If you started with a 1, then basically that is your scale factor. Okay? Okay, so that was it for this. Until next time, guys.